one strategy that we've learned for division? We really focused on two, but what's one strategy that we've learned? Do we see? Dealing out. That was probably the first one that we learned for division. Can somebody explain what the dealing out strategy is? What is that strategy? McKenna?
When you have the division problem,
Uh-huh.
one number is how many goes in those circles, and one number is how many circles there are.
Sure. If we think about it, every time I think of dealing out, I always think of like family game night. If you're the dealer, say you're playing Uno, one card for Ella Harris, one card for Eva, one card for Lucy, one card for me. Another card for Ella, another card for Eva, another card for Lucy, a card for me. You kind of just keep dealing out until you run out of cards or you run out of whatever it is that you're dealing. Sure, Parker, make it rain over there. Just kidding. What's the other strategy that we learned? Dealing out is a great strategy for division, but we learned another one to maybe make it a little faster. Cord? Yeah, I like to call it flip it, but yes, you're exactly right. My pen is not writing today. Flip it to use the inverse or the opposite operation, which for you guys is really convenient because you're really good at multiplication already. Aiden, what's up?
Literally, there are two strategies. I think we just switch
It would probably be helpful because we're going to be focusing on those two strategies today. Someone explain flip it to me, or maybe give me an example of using the flip it strategy. Parker?
6 divided by 2.
Okay, so we have 6 divided by 2.
6 divided by 2 is 6.
We got to switch the operation. Yeah, well, so if we're, there we go. So Parker said, okay, if we have 6 divided by 2 equals box, we can flip that around to be multiplication, to be box times 2 equals 6. Very cool. All right, we're going to focus on these strategies today. Like I said, some of this should, actually all of this should be a review. Make sure that we're ready to go for our test tomorrow. Okay? First strategy we're going to work with is the dealing out strategy. So go ahead and make a subtitle for dealing out. And on the computer, there is not that cool division sign. And so I have to use a slash. But if you see that slash, it's the same idea. So really this should say 44 divided by 6. Okay, that is really the division symbol, but on the computer. I don't have a division sign on my computer. Gotta make do. Okay? If I am solving this problem using dealing out, McKenna told me I have to draw some circles. How many circles am I going to draw? 600. No, raise your hand and tell me. Gabriella?
6.
How do you know? Why am I not drawing 24 circles?
Because then it'll take you a long time. And it's a lot. So that and it would be enough for 6 dots.
Okay. It would take a long time and it wouldn't quite make sense. Why else is it not 24 circles? Cheyenne?
Because 24 is an answer. Because the multiplication way would be 2 or 6 times the other part equals 24. And the division always starts with that.
Perfect. Yeah, that 24 is my total amount. 24 cookies, 24 pencils, 24 students. That's my total. I'm not going to make my student into a group. That would be painful. So I have 24 things being put into 6 groups. If you have not written that equation, go ahead. And we're going to make our 6 groups. I am a big fan of circles and dots. Except my marker apparently is not. 2, 3, 4, 5, 6. Yes, ma'am, Grace. Uh-huh. It is very, very similar, yes. There's a reason we learned that strategy first.
It's kind of.
It's very similar, yeah. Now, I will tell you, because most of you know, you just go 1, 1, 1, 1, 1. 1, 1, 1, 1, 1. Here's a slightly faster way if you want to try it out. We are just as good at counting by ones as we are counting by 2. Could that save us a little bit of time?
Yeah.
Okay, so let's do 2, 4, 6, 8, 10, and 12. Do I still have to keep going?
Yes.
Yes. All I've done is put 2 in each. Instead of going through and doing 1 for you, 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 I kind of skipped this step and just said, hey, 2 for you, 2 for you, 2 for you. Remember, everybody got the same amount, so it's still going to be fair, but this is kind of like a shortcut. Let's go back to dealing out ones. We were at, what, 2, 4, 6, 8, 10, 12. This will be 13, 14, 15, 16, 17, 18. Do I still have things to deal out?
Yeah.
I've only used 18. Sam, you say yes. Alright, 19, 20, 21, 22, 23, 24.
Yeah.
24 divided by 6 is 211.
No. 4.
I have a 2, a 1, and a 1. That must be 211.
No.
Wow, someone has done this, Brian. 24 divided by 6 is what? Raise your hand to tell me. Hint, it's not 211. Dylan?
4.
It's 4. I'm adding up what's in here. I have a 2, a 1, and a 1, which will give me 4. 24 divided by 6 is equal to 4.
So 4 times 6.
Good. Great, we're going to keep moving on. Okay? Alright, let's look at this problem. We're still using our dealing out strategy, but now we're going to try a word problem. Ricky bought packets of paper plates for her birthday party. They came in 6 packets. Brian, sit up. There were the same number of plates in every packet. She bought 42 plates in all. It's going to be a big birthday party. How many paper plates were in each packet that Ricky bought? Are we going to jump right into math?
No. You have to know the unit.
We need to know what we're doing. I've read the problem. What's next that I know I need to do? Some of you got lazy in your word problems in rotations. Ella Harris? Before that, before I figure out what math I'm doing, I need to know what I'm counting. I need to know the unit. What is my unit? Open up your notebook. What is my unit? What am I counting in this problem? Tajir, what am I counting?
Paper plates.
I want to know how many paper plates are in each group, or in this case, they're using the word packet. Go ahead and start writing an answer sentence. I could write. It doesn't need to be the exact same one that I have, but what are some answer sentences I could use? Mason, go for it.
There were blank in each packet.
There were blank what? Yeah, we need that. We need blank and then the unit. We can't just say there were blank. Blank what? There were blank paper plates in each packet. Cora, what you got? Are we counting packets or are we counting plates? Because I know how many packets she bought.
40.
How many plates are in a packet? I know how many packets she bought. It already told me that. Pizer, what you got?
There were blank paper plates in each packet.
Beautiful.
But we know that.
Hang on, Gabriella. We don't know how many paper plates were in each packet. We know how many packets they bought. And we know how many plates total she had. But we don't know how many came in each group. Now remember, I'm a big fan of bar models to figure out which math am I going to do. Okay, so let's go ahead and draw our bar. Okay. Brian, after I draw my bar, what's the very next thing that I try to see if I know?
Go line, 2 lines at the end, with the hole.
Yeah, I need to know the total, the whole. Do I know the total number of paper plates or the whole amount of paper plates?
Yes.
Yes. How many paper plates did she end up with? Allie? 42. You bought 42 plates. I know that already. 42 is my whole. Sweet. Do I know anything else? Raise your hand if you can find something else that I know. Because there's another piece of information that can help us. Lucy, what you think? We got 6 packets. So if I have all my plates lined up, there's 6 packets in there. So packet 1, packet 2, packet 3, packet 4, 5, and 6. 6 packets. Alright, now that we've kind of gotten our bar set up, can we write a math equation to figure out what we're solving? What's my equation going to look like? What math might I use to solve this problem? What math am I going to use to solve this problem? Parker? Okay, tell me a division equation. 42, because we know division always starts with the total number, divided by 6 groups, equals 5. What if you're like, nope, never mind. So I have 42 divided by 6. Remember, the strategy I'm using is dealing out. Am I drawing 42 boxes?
No.
No, please do not draw 42 circles. Please don't draw 42 circles ever. How many groups do I have? Ella? I have 6. Underneath this, let's draw our 6 circles. There's my 6 groups. Show me with your thumb, how comfortable are you at using a skip count first? I get it. I don't know, Miss Miller. Definitely not. Like on the last one, we did 2, 4, 6, 8, and then we went back with 1s. How comfortable are you skip counting? I got it. I don't know. Definitely not. Alright, we're going to give it a go. I know some of you are still not comfortable with it, but that's okay. What are the easy skip counts we can skip count by? There's 3 of them. Say them with me. 2s?
2's 5 to 10.
Cheyenne's the only one that knows?
Yeah.
2, 5, 5, 10.
5, 10, 15, 20.
Can I do my 10? Because if I do 10, 20, 30, 40, 50, 60, is that going to work with the 42 things? No. What about my 5s?
Yes.
5, 10, 15, 20, 25, 30.
No.
Is it going to give me close, though?
Yes.
Alright, so let's skip 20, 25, 30. Am I at 42 yet?
No.
No, so I'm going to keep going by 1. I'm at 30, Parker, hang on. 31, 32, 33, 34, 35, 36. Am I at 42 yet?
No.
No, keep going. 37, 38, 39, 40, 41, 42. 42 divided by 6 is 511.
No!
What's it gonna be? I'm saying this because I've seen kids do it. They see 511, that must be 511. Emma, what's it gonna be?
7.
Yes, it's going to be 7. 5 plus 1 plus 1 is 7. Parker, what you need, friend?
Instead of I can move the bar line.
You can. You could have totally done it in here. So 5, 5, 5. And I think most of you do when you do it on your own. I was just doing circles because that's what we did in the last one. But you could totally, Parker, do it up here. And that would be completely fine and probably more efficient because it's already done.
Yeah.
That's fine too. Totally fine. Grace, what's that? Mm-hmm. Sure. Sure. Yep. That would totally work. 100%. Yep. Lucy, what's that? Oh, yes. We need our answer sentence. There are blank paper plates in each packet. 4, 7. Show me with your thumb how you're feeling about the dealing out strategy. Thumbs up, fantastic. Thumb in the middle, okay. Thumbs down, I don't know what you are doing.
Fantastic.
Cool. Cool. Alright, so let's go try and work with our other strategy. So go ahead and turn to the next page. Put a subtitle of Flip It. And we're going to work on this strategy, because this was our other strategy for division. Now remember, I can't have a fancy division symbol on my computer, but this is what it says. The same symbol, just a little bit different. 20 divided by 10 equals box. The best way I can tell you to flip it is to think back to your part, whole. When we write a division problem, what are we starting with? Am I starting with a part or am I starting with the whole? Whole. I always start with the whole. I got a bunch of donuts. I'm going to start with all of my donuts before I start passing them out. Right? Okay. So this is always whole. Always. Division always starts with your total amount because you got to pass them out. It wouldn't make sense to start with some of them. That would be silly. Divided by, what is 10? Part. And we're not going to have another whole. That would be weird. Equals part. Now, if I'm turning this around into a multiplication equation, what can I start with if I'm doing a multiplication equation? Damien? I'm going to do a part. And then what, Damien?
Times part equals whole.
Alright, let's fill in our parts and our whole. Let's fill in our parts and our whole. What's the first part I could write? Sam? I could do 10 times, our other part is box, equals 20. For a lot of you, this multiplication equation is a lot easier to solve in your head than that division equation. And that's totally fine. 10 times something equals 20. What? 10 times what equals 20? You should all have your hands up because you know your 2s, 5s, and 10s. Aiden? 2. 10 times 2 is 20, which means 20 divided by 10 is what? 2. Alright, let's try another word problem. Try another word problem. Brian, what's up?
The answer is at the beginning of the total.
What do you mean?
2 is at the beginning of the total. The answer.
So it's not going to be, I think what's confusing is the language that you're using. You're saying answer, which 2 is the answer, but 2 is not the total. So you're saying total and answer as meaning the same thing. 2 is the answer, you're correct, but remember, what's our total or our whole? 20. So that's why I think people were confused. But yes, 2 would be our answer. You're good. Alright, let's look at our word problem. Elizabeth wants to store 36 trading cards in plastic sleeves. Each plastic sleeve can hold 4 trading cards. How many plastic sleeves will Elizabeth need? Yeah, this should look very familiar. I'm going to jump right into math, right? No. What do I need? What do I need, Emma?
An answer sentence.
Please write an answer sentence. This one's not too tricky because the question is not too tricky. We got our answer sentence. We know we're trying to count plastic sleeves. I'm going to go to my bar model to figure out, am I adding, subtracting, multiplying, dividing? I don't know. So I'm going to draw my bar. Maybe draw my bar. After I draw the bar, the first thing I try to see, if I have, is going to be what, Gabriella?
What?
After I draw my bar, what's the next thing I'm going to try and see if I have?
Your whole?
The whole. Do I know the total of anything?
Yes. Yes.
Cheyenne?
Yes, and it's 36.
I know I have 36 trading cards. She's not getting any more. She's got 36 of them. She's not getting any more of them. What else do I know? She's got her 36 trading cards, and I know something else. Corey, what else do I know?
Each trading card can hold 4.
Each sleeve can hold 4. This is where it gets a little tricky, because do I know how many sleeves I need yet? No. So this is where I either want you to just guess and check. Okay, well let's try 2 sleeves. 4 over here, 4 over here. Does 4 and 4 give me 36? No.
Equity.
It is kind of like an equity. Well, let's try 3 sleeves.
No, that's 6.
It's
That's
not
not 6, that's 12. That's 12. That's 12.
Okay. Could I write an equation to solve this?
Yes.
What would it be? What would it be? I know my whole, and I know how many are going to go in each group. I just don't know my groups yet. Ella?
36 divided by 4.
36 divided by 4 equals 5. Now, division I know is not your favorite. So let's use our flip it strategy and make that a multiplication equation. What is going to be my multiplication equation? Brian, what's it going to be?
4 times 5 equals 36.
4 times something equals 36. This is the part where I definitely recommend you guess with 2s, 5s, and 10s, and then go from there. Let's try 2. 4 times 2? Is that 36?
No.
No. Are we even close? No. So it's not going to be near 2. All right, let's try 5. What's 4 times 5?
20.
So it's still too small, but we're getting closer. All right, let's try 10.
No. That's 40.
But hey, is it way too high?
Way too high. No. It's a little high. It's
No, it's really close. 36 is pretty close to 40.
Just take away 4. How about 8?
Just take away one group of 4. What?
Let's try 8. Let's try 8.
Try 8. Don't make it more work for yourself. Go ahead, try 8.
4 times 8. No, I can break it. 32. Okay, so 32. Try 9. Try 9.
Okay, pause for a second, and I want you to think a little bit logically, because you guys just made this way more work for you than you had to. Pause, I don't want any voices. When we did 4 times 10, and we got 40, right? Remember that? That was really close to 36. It was only one group of 4 away. So if I'm at 10 groups of 4, and I know 36 is one more group less, can I just change this to 9?
Yes. Yeah! I was thinking of that. Yes. 4 times 9.
It's 4 times 9 equals 36, is that true?
Yes.
So if 4 times 9 is 36, what's 36 divided by 4?
9.
She needs how many plastic sleeves?
9.
Okay.
4 times 8 4. It's 32.
Yeah, is that 36?
No, but it's close.
It is close. But what from your hand?
Hey, we forgot to do our bar. I did our bar.
Oh yeah, you can fill in your bar. Sure. How many groups would I need to draw?
9.
I would need to draw 9 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many do we know goes on each of those groups? 4. That is completely right, Cheyenne. Thank you. 1, 2, 3, 4.
The first one looks like a 9.
That's fine. Okay. All right, we're gonna switch gears. How are we feeling about division?
It's okay.
You can use both strategies. You can pick one strategy to use. I don't care. Pick what works for you and rock and roll. These are the 2 main strategies that we've learned. If you prefer dealing out, deal out all the way. If you prefer flip it, do it all the way. Okay? I don't care. But find something that makes your brain happy and go to town. Okay? Taysir, what's up?
I also have a different strategy.
First, we've dealt a lot with unknown numbers. And we know that unknown numbers can be boxes. We know unknown numbers can be letters. They can be pictures. Any version of that can represent an unknown number. And we know if we can't solve for an unknown number, the best strategy is usually to flip it. Hey, we just did the flip it strategy. That's pretty convenient. Okay? You just need to title your next blank page unknown numbers. You don't need to write the rest of this. We already know what unknown numbers are. Brian, go ahead and sit down because you're being too much of a distraction. Alright, so here's a problem where we have an unknown number. We have a giant star, and giant stars are not numbers. They would be stars. Okay? A lot of you can look at this and say, ooh, I know it. Easy peasy. which is fine. But let's pretend, I'm not so sure about this.
Okay.
Could you flip this
Yes.
around?
Yes. Yes.
So I'm going to remind you, no, that's not what we're doing. We're not calling out the answer. I know you can solve that. You passed first grade. I'm not concerned on you being able to tell me what that number is immediately. Eva, up here, please. I want to see, can you flip that? Because if you can flip something easy like this, you can flip the harder one that's coming up. Now remember, this is addition. Please write this down. Put a box in place of star, because I don't need you drawing the star for 8 years. Part plus part equals whole. What operation is in this equation right now? What operation is in that equation right now? Cheyenne?
Addition.
Addition. So if we're going to flip it and do the opposite, what operation am I going to use? McKenna? Subtraction. How do I write a subtraction problem? Courtney, what do you think?
I think it's 13.
13, my whole, minus,
10
and
equals in a box.
box, star, whatever. This would be our whole minus part to give us the other part. Make sure this is written down in your notebook. Times 2 equals 6. Most of you can look at that and immediately know what box is. That's cool. Awesome. But let's practice some more flipping that around in case we didn't know what box was. How would I flip that equation around? Yes, that's correct. Because multiplication and division are inversely related. They are opposites. Somebody tell me, what is this going to be flipped? Go for it, Sam.
6
Sure. Sure. What is the star in my first equation? Damien? 3. What is the box in my second equation, Cord? 3. Are we good with this? Yeah. Right. In a moment, you are going to get a half sheet of paper, and it's filled with unknown problems like what we just did. You have to figure out what's going to go in that shape. Okay? If you are having a hard time solving it, if you're having a hard time figuring out what goes in that unknown number holder, try flipping it around and see if that makes your brain happy. Okay? Does that make sense? You might